What I'm going to do right now is I'm going to solve a one-step equation of a fraction. So the first thing I'm going to do is I'm going to read my equation. It says 4/5 x equals 2/10. I always want to get the x by itself. So what I need to do is I need to do the reciprocal. So I'm going to multiply by a reciprocal. That means that my denominator becomes my numerator, and my numerator becomes my denominator. And the reason that happens is because when I have a 5 on top and a 5 on bottom, I'm able to reduce those to 1. Same thing with my 4. I've got a 4 on top and a 4 on bottom, which means that x is left alone on the left side of my equation. Now, if I do that to the left side, I've also got to turn around and do it to the right. So I need to take this times my reciprocal, which was 5/4. When I do that, I can, two options, I can multiply straight across and I can get 10 over 4 times 10 is 40, and then I can reduce here, or I could have reduced earlier. I'm going to go ahead and reduce here. The zeros cross off, which means that I'm left with 1/4. So x equals 1/4. So you're going to do the same thing on number 2. Number 2, the equation is 3/7x equals 1/7. So you're going to start by timesing by the reciprocal on both sides of the equation. Now let's check and see how you did. So my reciprocal would have been 7/3. The 7's reduce, the 3's reduce. Now I have to drop down my x equals, now I need to do the same thing on this side. 7 and 3, and I'm going to be timesing by that. So the 7's actually in this case will cross off, which means I'm left with 1 on top and 3 on the bottom. So I have a x equals 1/3. Alright, now this equation is a little bit different for number 3. What I've got is I've got a mixed number this time. So I've got a whole number of 2, a fraction of 1/3 x equals another mixed number of 5 1/2. So my first step is going to be taking that mixed number and turning it into an improper fraction. So I'm going to take the denominator times the whole number, which will give me 6, and then I'll add on the numerator, which is 1, 7. So I'm going to have 7/3 x equals, same thing over here, times and add. So that's what I call the swoop method of 10 and 1, which makes 11/2. Now I do the same exact thing as we did on 1 and 2. Reciprocal, which is 3/7. So those cross off, x is left alone. I always want to get x by itself. Times reciprocal over here, 3/7, which means that I have 33/14. Now I'm thinking that those don't reduce, so I just need to turn it into a mixed number because that is an improper fraction. So 14 will go into 33 2 times, so that's going to be my big whole number. That was 28, so now I take 33 minus 28, and this will give me my numerator, so I have to borrow. That gives me 5, so I've got 5 left over out of my denominator, which will be 14. So my answer will be x equals 2 5/14. Now it's your turn for number 4. Your equation is 8 4/5 x equals 10. So what you need to do is you need to start by turning this mixed number into an improper fraction. Times it by your reciprocal on both sides of the equation to solve for x. Alright, let's see how you did. So I'm going to take 8 times 5 and then plus 4. So that's 44/5 x equals, now I don't really have to worry about the 10 other than I'm going to turn the 10 into a fraction. So I'm going to put it as 10/1 times the reciprocal, 5 on top, 44 on bottom. Those cross off, that crosses off, x drops down by itself, times reciprocal on this side, 5/44, which gives me 50/44. I can reduce, but I'm going to go ahead and turn into a mixed number of 1 and 6/44, which I can actually take that, slide my, squish that down, I guess, just a little bit. Alright, so now what I've got is I need to reduce this part right here. So x still equals 1. That's not going to change, but I can divide both of those by 2, which gives me 3 on top. Divided by 2 is 22. And 3 and 22 cannot reduce anymore. So my answer is 1 and 3 over 22.